Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. Okay, so the paper went well, right, for chemistry and physics. Tomorrow is mathematics. So I am here with one session which is very important for mathematics. What is there, bacha? You have to know the formulas. If you know that, you'll get the questions on them. Okay, so I've taken one session for entire formulas in PU1, PU2 that you have to remember. Okay, if you know all of this, you get to have a very, you can say that your preparation is complete and you can solve any questions coming from these topics. Okay, so again, everything is done. PYQs are done. Top 100 is done. If you want to watch top 100 questions, you can watch. The session is available. If you want to see the PYQs, you can watch my top 30. You can watch my for PU1, PU2 both. Okay, so basically why this session today I'm taking here, because after looking at the questions of chemistry and physics, we saw that a lot of questions coming from PU1 as well. Usually 15 questions on an average was coming from PU1. This year more than that is there. Okay, means most of the questions are like 15-20 questions are coming this year. Okay, in the first paper of physics we saw. Okay, so if that is the case, all right, let's say similar kind of question comes, 20 odd questions come from the PU1, then bacha, the formulas of PU1 becomes very important, right? So this session is for that. So I'm going to start with PU1 first. I'll show you the formulas of PU1 chapters, then you have to do the PU2. Okay, if I miss some chapters over here, for example, I've not taken conic section today. If you want, you can watch that session in my master stroke session of conic section. Go ahead, watch that out, okay, and learn the formulas from there. Okay, so apart from that, let's start the session right now that we have in this. Is first thing is which trigonometry I've taken over here. So if you see the question, first type of question or question application that can come in this formula is conversion of radian to degree measure. You should know this. Degree measure is given as 180 by pi into radian measure, and the radian measure is given as pi by 180 into degree measure. Okay, this conversion is very important. Now if you move forward from this, what you have over here, please check. You have this table is very important, even useful in the inverse. Okay, you can see this question, though this table is useful in ITF, this table is useful in vector 3D also, vectors 3D as well, where we talk about vectors and 3D part mostly, where we talk about dr and dc's. When we talk about direction cosines, there this becomes very useful. Okay, when we talk about that alpha is given like this, beta is given like that, what is the value of gamma? Okay, so this table is highly important. Sin theta, cos theta, tan theta, others you can find from here only, but mostly questions come from this type of only. Okay, usually from cos or sin most of the cases. So alright, very important. Sin 0, 30, 45, 60 and 90, 0, 1 by 2, 1 by root 2, root 3 by 2, and 1 is for sine. And just reverse if you take that for cos, because of the complementary ratio, 1 root 3 by 2, 1 by root 2, 1 by 2 and 0, and the ratio will be 0, 1 by root 3, and we have a 1 root 3 and undefined. Okay, so please remember this table, highly important. I know you already know it, but my job is to come here and explain you everything which is very relevant for all of you. Okay, now sign convention, this also plays very important role. Which quadrant, first, second, third, fourth, which quadrant, what is positive? Quadrant 1, quadrant number 2, quadrant number 3, and quadrant number 4. Summary, all 6 here, all 6 ratios. There are total 6 ratios. Please check. Sin, cos, tan, cot, sec, cosec, all 6 are positive here, sir. In the second quadrant we have only sin and the cosec as positive. In the third quadrant we have tan and the cot as positive, and the fourth quadrant we have cos and the sec as positive. Okay, cos and the sec as positive. Please check. Fourth quadrant, cos and sec is positive, rest all is negative. You have to know it. Okay, and you know the boundaries, right? 0 to pi by 2 is for the first quadrant, second is pi by 2 to pi, third is pi to 3 pi by 2, and the last is 3 pi by 2 to 2 pi, 360 degrees, right? Okay, sir, so we know this much. Okay, now graphs, if you check for sine and cos, again very useful in the questions of AOI. Remember, sine is like this. Okay, sine is like this. We have seen the curve like this, remember? So this is the sign where this is going to be x and y. What is the value of x, bacha? X will be in the angles, right? Okay, so we have 0 over here, we have pi over here, this will be pi by 2, this will be minus pi by 2, okay, and likewise this is minus pi, this will be same thing over here with 2 pi. This maximum value, bacha, is given as 1, and the minimum is given as, please check, minus 1. Okay, so your range is minus 1 to 1, your domain is all real numbers for the sin x. Okay, repeats after interval of 2 pi. The graph, if you see, it'll repeat after the interval of 2 pi, 0 to 2 pi, again it will continue like that. Okay, Again, if you check for the cos x now, the graph is a little bit different. Starts from 1 and goes like this, correct? Please check. Okay, so this is my 0, pi by 2, pi, okay, and this will be, sir, what? This will be 3 pi by 2, and this will be 2 pi, so this will be 2 pi, okay? Again, this maximum value is 1, this minimum value is nothing but -1, okay? The graph of y equal to cos x. Please check. Again, repeats after the interval of 2 pi. The periodic on the interval of 2 pi, cos x as well. Range is -1 to 1, domain is all real. Moving on for tan inverse, y equal to tan x, simple curves, okay? Please check, this is my curve, right? This is nothing but, sir, pi by 2, and this is nothing but, sir, minus pi by 2, okay? Minus pi by 2, this value is 0, please check, okay? Great. And again, you can have more, graphs like this. It'll continue on both sides. Okay, so your domain, if you check, everything except for the odd multiple. What is this represents? Odd multiples. 2n plus 1 is odd number, right? So odd multiples of pi by 2. Odd multiples of pi by 2. You have to take that out. Please check. Over here the function is not defined, sir. Over here the function is not defined. You are reaching this to infinity. Here negative infinity. This is going to be plus infinity. This is moving towards negative infinity. So your range is all real, but your domain is all real except for odd multiples of pi by 2. Works? Chaliye. Moving on. Trigonometric functions, some properties are there. Please check. Sine of minus x is, sir, minus sine x. Cos of minus x is, sir, cos x. Cos of minus x is cos x. Okay. Odd and even function, we know this. F of minus x when equals to f of x, we call this function to be even, and when we have the other case, we call this to be odd, sir. This is odd case and this is even. Please check. Okay. Again, cos of pi by 2 minus x is going to be sine. At pi by 2, sine and cos will convert to each other. The same goes with tan and cot. Okay. This is the pair, right? Sine cos, tan cot, and sec cosec. These are called as complementary pairs. Remember, complementary ratios. Complementary ratios. What happens? They convert to each other at odd multiples of pi by 2. At odd multiples of pi by 2. At odd multiples of pi by 2. What will happen? Please check. Pi by 2 is there, no? Odd multiple 1. So we get cos becomes sine, sine becomes cos, cos becomes sine, sine becomes cos, cos becomes sine. Okay, cos remains cos because it is not odd. It is even, sir. Pi by 2 into 2. How much is that, bacha? Cancels. So even multiple, right? So at pi it will remain same. So at multiples of pi, right? Pi, 2 pi, 3 pi, what happens? Remains same. Remains same. What remains same? All the trigonometric ratio remains same. Okay. And what about this, sir? Sine plus minus. We know this rule, right? This rule only. Quadrant rule. 1, 2, 3 and 4. Sir, question will come on this. The question might not come on this, but application might be there in the problems of integration, differentiations, wherever the trigonometry is coming for you. Okay. So the application will be there. That's why remember this. First quadrant rule was all positive. Second was sine and cosec positive. Third was tan and cot positive. And fourth was cos and sec positive. Please check over here. Cos pi by 2 plus x, which quadrant, sir? Angle pi by 2 plus x, which quadrant, sir? Second quadrant. Second quadrant, only sine cosec is positive, sir. Cos is there means negative. We had cos, right? That's why negative sign over here. That's why negative sign over here. All right. So I have some extras I've taken. Some marks. So I'm going to take this out. Please check. I'll remove this mark so that it makes simple and easy understanding for you. What you can do is get this session's PDF. I've taken almost, I think, close to 100 slides I've taken, okay, where I'll explain you all the formulas. Please get these slides, this PDF in the WhatsApp channel, okay. I'll put right away after the session over, okay. You can get the session's PDF available in the WhatsApp channel and revise from that, okay. Works. So understand this from here. Odd multiples of pi by 2, they will convert to sine cos, tan cot like that. And again, vice versa is also true, right? Vice versa is also true. both side are true, right? Okay, in at this case pi, 2 pi, 3 pi remains same, all the ratios. Sign will be taken from the quadrant rule, built from the quadrant rule. I already explained this to you in the previous few slides. Okay, please go ahead. Same thing is over here, bacha. Sin pi plus x, which quadrant, sir? Third quadrant. Pi plus x is 180 plus x, third quadrant. Only tan is positive, that's why minus x. Sin x we have 2 pi minus x, sir. Fourth quadrant, sin is negative. This bacha, fourth quadrant, cos is positive. Like that we have, please check. The formula of cos of a plus b is cos a cos b minus sin a sin b. Over here cos of a minus b is cos a cos b plus sin a sin b. Please check, sin of a plus b is sin a sin b, sorry, sin a cos b plus cos a sin b. Okay, cos x sin x in the sin y in this case. Sin of x minus y is nothing but, please check, sin of x cos of y minus sin of y cos of x, sin of y cos of x. Okay, remember these formulas. This is very, very important formula. Tan x plus y, tan x minus y. I know you already know this formula. I'm not saying that you don't know. You have to revise it. Okay, you have to revise it. Even though if you know, please go through the slides and revise these formulas for tan of x plus y, tan of x minus y, cot of x plus y, cot of x minus y. You'll do that, right? Yeah. Chaliye, I'll just erase some extra markings that I've done. Okay, moving on. We have same thing. This is again very, very, very important formulas. The first three. Cos 2x, cos square minus sin square, 2 cos square x minus 1. 1 minus 2 sin square x is also there. We have cos 2x in terms of tan also like this. Okay, same way, sin 2x is 2 sin x cos x also in terms of tan. Tan 2x like this, please check, 2 tan x upon 1 minus tan square x. Okay, sin 3x is there, 3 sin x minus 4 sin cube x. Cos 3x is there, 4 cos cube x minus 3 sin x. And tan 3x is 3 tan x minus tan cube x upon 1 minus 3 tan square x. Formulas, you know, I know you know, but you have to revise it again. Okay, very important. This because the questions will not come on this formulas, but application is there in the case of differentiation, integration. So please remember, when you're doing, dealing with your what do you call, substitutions, this formula becomes very, very useful. You will do that, right? Of course you will. Okay, cos x plus cos y, please check. We have 2 cos of x plus y up into cos of x minus y by 2, cos of x minus y. You can see some of the questions are coming from this topic also. Okay, I have shown you some questions. I have to solve these questions also. So please remember this formula as well. Okay, please check. Cos of x minus y, sin of x plus y, sin of x minus y. In terms of, for cos we have both cos, for both cos with the negative sign we have both sin. Cos with plus sign we have both cos. Cos with negative sign we have both sin. Both sin we have sin cos. With positive sign, sin we have cos coming as x plus y by 2. Okay, yeah, formula you have to remember, but of course. Chaliye, same result. This and this can, actually if you know this one, you can understand this one also. From there only it comes. But yes, you have to remember this 2 cos x cos y. This result is there. 2 sin x sin y. This result is there. And likewise, all the 4 are very, very important. So please remember all the formulas. Okay. Yeah. This one not that much, but yeah, these are very important. Questions can be asked on this. Okay. In the calculus end, please check. So you can get all these formulas in the WhatsApp channel. We'll put the PDF of the session right away. You get it from there. Okay, great. Integral power of I, please check. You can write I power 0 as 1. What is the I square, sir? I square is going to be simply I power 1. It will be, sir, I only. Okay, and I square will become, sir, what, bacha? Minus 1, right? Likewise, again, have a look. So if you have z1 plus z2 the whole square, we can write this as z1 square like this. Please check. Continue like this. A plus b the whole square, a minus b the whole square, a plus b the whole cube, a minus b the whole cube. Okay, and a square minus b square is also there. Basically, these identities of algebra is applied on complex number as well. Z1 and Z2 are complex numbers. Okay, the modulus of conjugate of complex numbers, please check. Modulus and the conjugate. Modulus is, this is, if I write this modulus, this function as a plus I, we know mod of z is nothing but square of the real part, whether positive or negative doesn't matter. Okay, that's the value, plus imaginary part square. Okay, imaginary part square. Okay, and conjugate, bacha, if I'm writing this, let's say z as a plus I b na, then conjugate we have sign as like this. Conjugate will become a minus ib. Okay, only the imaginary part will be changed to negative sign. Basically, sign change has to be there in the conjugate. Please check. All right, a few notes. A complex number z is purely real if, of course, this condition is true. Remember this, very, very useful. Okay, very, very useful, sir. All right, what next we have? Complex number is purely imaginary if this cases. Both the cases are extremely useful. Please remember. Conjugate is same as the complex number, or conjugate is negative of the complex number. It means it's going to be purely imaginary and purely real. What's the meaning of purely imaginary, sir? It means 0 plus IB. This is the purely imaginary. What is the purely real, sir? A plus I0. This means A plus I0. That's the meaning of purely real. Okay, please check. Properties we have, mod z is 0, it means z is 0, that is real part is 0 and imaginary part is 0. Both has to be 0 at the same time. Remember, mod z means z is 0, basically real is 0 and imaginary is also 0, sir. Okay, mod z is same as conjugate z or mod of negative z, same bacha, because you're talking about square terms, no, in the root, and the sign does not matter in that case. Okay, so and this real value will be always between the negative mod and the positive of the modulus. Okay, so basically if I'm talking about this a value, no, so if I'm writing this, let's say z equals to a plus ib. Okay, so I'll have this a lying between, bacha, please check, root of a square plus b square minus root of a square plus b square. From here to here, always it will lie like that. Okay, same goes in this case of imaginary as well. Okay, check. Moving on, some properties to remember. I'll just remove this because same thing is written over there, so no need to write it again. Let's move on. Some more properties. Z into Z conjugate is given as mod of Z the square. Z1 into Z2 is given as, I can separate the modulus, Z1 into Z2 mod, individual mods. Okay, if I'm taking about the quotient in the modulus, we can take again individually, mod of Z1 upon mod of Z2. Have a look. Some more properties are there for whole square of mod of Z1 plus Z2, mod of Z1 minus Z2, and please check the result when you take the sum of these two. You get simply this condition, mod of twice the mod of Z1 square plus Z2 square. Okay, if you have a constant over here, a Z1 minus b Z2 the whole square, again you get this relation. This is also very important, sir. Okay, very important property. I've solved a question on this in one of my sessions. Okay, you simply take this coefficient outside and take the squares of that and take the factorization like this. Okay, remember these formulas where a b is a real number, they're constants. Okay, moving on. Properties of conjugates, please check. Conjugate of conjugate will become the number itself, complex number itself. If you're talking about, I already explained you this part, this although I already explained it to you. Okay, real parts and imaginary parts, please check. And if I have fourth one, z equals to z bar, means z is purely real. Done this as well already, sir, please check. Z into z bar bacha is going to be this is square, same thing. Remember, this is what, so this is going to be mod of z, right? What is this bacha? Mod of z. Okay, square, excuse me, from here I think I took it over here, right? Yeah, fourth property. This fourth property is same as this sixth property. Okay, great. Please check. If I am having the conjugate over here, I can write it individual conjugates over here. I have the again same goes in the case of quotient as well, product as well, and if you have a constant alpha bar will become f of z bar, where the function is defined. Okay, basically alpha is a function of z. Okay, I can write alpha conjugate as same as function of z conjugate. Okay, let me remove the markings, not required, but you have to know the formulas. You have to know the formulas. Complex numbers, almost one question comes every year. This year might be two, because I can see that in the previous questions, sorry, in the chemistry and physics, the question was like that. Especially in physics, there were almost 20 odd questions from the PU1. That's why very important. Okay, Argand plane and polar representation. Let's take the Argand plane first. So in the Argand plane, what we have of course we have x and y axis. X represents this real part and y represents this imaginary part. It represents imaginary parts of the real number, sorry, of the complex number z. Okay, so basically if I'm writing here, let's say number z equals to a plus ib, right? So this will be, a will be on this and b will be on this, b will be on this. Okay, we'll have a comma b like this. Okay, and what about polar representation, bacha? So yes, so we can write a number like this as r cos theta plus I r sin theta equals to the number, complex number in the polar form, r cos theta and I r sin theta. If you ask me the value of r, it will be given by x square plus y square in the root. This is the value of r. Okay, and if you ask me the value of theta, theta is given by tan inverse of y upon x. So if they ask me to convert, okay, between this is the relation. Z is given by r cos plus I r sin theta. How do you find r? Using this formula. How do you find theta? Using this formula. Tan inverse of y by x is the theta formula. R is root of x square plus y square. Okay, great, sir. These two are important formulas for the conversions. Done. Q roots of infinity, sir. Whenever we have this function zq equals to 1, we will have 3 roots. This is will be the real root, other two are imaginary root, given as, please check, mass 1 by 2 plus I root 3 by 2 and mass 1 by 2 plus minus I root 3 by 2. They will be complex conjugates. They will be complex conjugates, please check. Okay, and of course this relation is very, very important. We have used it so many times, remember? Yeah, in case of matrix we have to solve the question like this: 1 plus omega square is 0, omega q is equals to 1. What is this relation, bacha? Sum of roots, and this is going to be, I think, what is it, product of roots, right? Yeah, products of root. Okay, moving on now, sir. Now we are into binomial theorem. Binomial theorem. Okay, so I have not taken everything in the binomial theorem. I have taken some relations that is very important that you might forget. So what is that? If I have, let's say this is the formula, right, for a plus b power n. If I am replacing this with minus b, I'll have this result: nc naught a power n minus nc1 a power n minus 1. Basically, whenever you have odd powers of b, because b has a negative sign. So whenever you have odd powers of b, it will become negative. Please check. B power 1, right? So odd, we have minus sign. B power, see, power is 2, even. So we have plus sign. If you go for b cube, again you're going to get negative. So you'll have the result as, please check, plus minus like that. Odd powers of b will give me negative terms. I hope all of you agree. Okay. Chaliye. So let's just erase this all. Great. Moving on. We have few notes over here. Plus and minus appear alternatively in the binomial theorem, of course, because of the reason, but what? The odd powers of b. Okay, great. If you take a value as 1, this becomes expansion 1 plus x power n. What do you get? nc0, which is nothing but 1 only. nc0 is 1. nc1, what we get? nc1 x, nc2 x square, nc3 x cube, so on till ncn x power n. Okay, ncn x power 1 when you have the first as 1, sir. Okay, great. Taking a equals to 1, b equals to x in expansion of a minus b. If you take this expansion, you will have alternate power. Wherever the x is odd, having the odd power will become negative. Please check. X power 1 means negative. Again, if you take x power 2, it will be positive. And likewise, if you go about x power 3, it will become negative one more time. Okay, negative one more time. All right. Fourth property is what, bacha? In binomial, sum of the binomial coefficient, if you add them, you'll get c0, c1, c2 plus cn equals to 2 power n by taking x equals to 1. Correct, na? Right? What are you gonna get? Please check from here. If you do that, you get 1 plus 1 becomes 2 power n. It will become nc0, nc1, nc2, ncn, like that. Same thing is written over here. nc0 is called as, this is my nc0, this is called as nc1, like that. This is called as ncn. ncn will be given by simply, please check, 2 power 1 plus 1 power n means 2 power n. 2 power n. Okay. So we have result over here. Please check. If I am writing here c0, c2, c4 like this, and c1, c3, c5, if I separate this, I get 2 power n minus 1. Okay, and this already told you this is going to be 2 power n. Okay, number of terms in the expansion will be given by this formula: n plus r. N plus r means number of variables. Okay, r represents number of variables. Okay, so n plus r minus 1 upon r minus 1. Sorry, what is it? N plus r minus 1 c r minus 1. You know the formula of NCR and NPR, right? NCR is given by n factorial upon n minus r factorial into r factorial, and we are talking about NPR. Let's say we have n factorial upon n minus r factorial. Please check. There are two formulas, very, very important. Remember these as well. Okay, moving on now, bacha. We have now in the limits, please remember, some, I have not taken everything, but some important results I've taken in the limits. When we're talking about algebra of limits, let's say we have, which let's say I'm talking that this limit and this limit exist, means function fx and function gx limit exist. Okay, after that part, if I'm taking, let's say, sum and difference of the functions, limit of sum and difference of the function will remain basically limit you take first, and then you can add or subtract. First take limit and then add or subtract. Same goes over here. You can multiply, first find the limit, then you can multiply. Over here, first find the limit, then you can take the power. Okay, if this is taken as L, this part is taken as L, please check. Okay, again, if you have the function in the quotient, you first take the limit, then you can take the quotient. Okay, of course this has to be non-zero. We have to have the denominator as non-zero value. Okay, chali, if you have 1 by fx, you can take limit first, then you can take the ratio, not a problem. Okay, same thing, if this is equals to c and this is equals to l, I can write bacha this as also l. Basically this is the combination, right? Goff, composite. Okay, so we have written this value as at a as c and at c it is l. It means it will become simply l at a. The Goff will become at a simply equal to l, because f at a is c and g at c is l. So combination is Goff for composite. Please check. Okay, and again we have modulus also is there. So first you take the limit, then you apply the modulus. Not a problem. Got it? Simple enough, right? Okay, so some algebra of limits is mentioned over here. I'm going to move on now. Okay, so I don't have to erase this, right? But I'll just erase some of the things which is not making much of the difference. So I'll just erase these markings. Okay, let's continue from here now. Okay, moving on now. Limit of e power fx is given like this. You can take the limit of the function first, then apply exponential function to this. Same goes in the case of log also. Take the limit of the function first, then apply log to it. Okay, of course this value has to be more than 0, because log is not defined for a function less than 0, right? Remember the graph of log? This is the log function. You don't have a value of x less than 0. Domain is going to be 0 to infinity. 0 is open actually, infinity here, and of course, yeah, like that. Great. Okay, this is your domain of log function, 0 to infinity, only positive real numbers. Evaluation of limit by using some standard results that we have. One is for the exponential function, where you remember x power n minus a power n upon x minus a becomes n times of a power n minus 1. N times of a power n minus 1. Okay, where n is a natural number and a is any real number. Okay, few more we have. Where x tends to infinity, when we're looking in that case, what are you going to do? In such cases, we have to divide this. We have to make sure that degree of fx and gx, and then divide numerator and denominator by the highest power of the variable term. Okay, why, sir? Because you get this value when x tends to infinity, right? You get this value equals to simply 0, because it will become 1 upon 1. So 1 upon infinity, right? It will become what, bacha? 1 upon 0, right? It will become simply 0 upon 1. Answer will be 0. So if you have not watched my trick session, right, I've given two trick videos. I've talked about these concepts in detail over there. So please go ahead and check my session on the short tricks for the KCET mathematics, recently published only on the channel. Go ahead, check it out. I've given more tricks in this kind of questions for the limits. Please check it out. Okay, what have we have next over here? Evaluation of the limits of greatest integer function. If you approach from the positive side, you get the number itself. Think about it. I'm gonna go 1 point something, 1.00000 over here somewhere 1. What's the answer, bacha? 1 itself. But if I approach this number 1 from the left hand side, 0.999999 like this, what I get the answer as? Please check. This is 9. Okay, doesn't look like 9, sir. Looks like some weird a variable. Okay, so let me write this as 9 only. 0.9999 like this. Okay, somewhere I take, what's the answer, bacha? Answer will be simply 0. So if you approach the number 1 from this side, you have the number 1 itself. You approach from here, you get the 0 itself. Okay, so you get a and a minus 1. Can they be equal? No. It means limit does not exist for any GIF. For this function GIF, limit, remember, does not exist. Where, bacha? At integers. At any integral point, okay, means negative or positive integers, the limit will never be existing in nature for GIF, for greatest integer function. Got it? Great. Moving on. Okay, because for the limit to exist, what we say, bacha? For the limit to exist, what we say, sir? We say LHL equals to RHL. We say LHL equals to RHL. Okay, have a look. Some trigonometric functions limit. Sin x by x is going to be, sir, 1. Even if you take x by sin x, you can take this over here. It'll become, please check, it'll become 1 upon sin x by x. I told you I can take limit over here as well. What I get? 1 upon 1. Answer will be 1 only. So whether it is in the ulta form also, even if it is in the reciprocal form, you get the answer also 1. So see, tan x by x is 1. So this also becomes 1 only, right? Sin px by px, bacha, becomes again 1, even if the P is constant available over here, but understand I should have P at both the places. Same goes in case of tan also. Tan Px by Px is again limit x tends to 0 will be equal to 1, sir. P is any constant. Moving on. Subsets, now we're talking about the set theory. Okay, so subsets, please check what the subsets are. A and B, B any two sets. Then A is called subset of B if every element of A is also an element of B. Also an element of B. And we represent it like this. A is a subset of B. Okay, read as A is a subset of B. Please check. Few notes are there. Every set is a subset of itself. Okay. Second, the empty set is a subset of every set. Basically, the null set bacha is subset of every set. Okay, great. Let A and B be two sets. Then we have A subset of B is given as, please check, A belongs to, if A belongs to A belongs to B also. Great. And understand this, NA means cardinal number of A will be either less than or equal to cardinal number of B. Okay, NA represents cardinal number of A. Okay, number of elements in A. If I have NA more than NB, then I cannot say A is a subset of B. If I have number of elements or cardinal number of A more than the cardinal number of B, I cannot say A is subset of B now. Okay, if A is subset of B and B subset of A, then we call actually A and B will be equal sets. Okay, means if they are both subset of each other, if I say A is subset of B, B is also subset of A, it means they are actually equal to each other. So A equals to B. Okay, total number of subsets is given by 2 power n. Very important formula, 2 power n. Okay, 2 power n is the formula for total number of subsets. Okay, containing n elements. Okay, chaliye, means there's a set A, let's say, which has n value is nothing but n. Means cardinal number of set A is nothing but n. In that case, we call the answer to be 2 power n for the number of subsets, also called as power of a set. This is also called as power of a set. Moving on, proper subset bacha. In this case, A and set, what we call, understand, we have given a symbol over here, right? No, we write it like this. A is a proper subset of B. Okay, means please check, there will be at least one element in B which is not present in A. That's how we define it. At least one element in B which is not in A, means number of B has to be more than number of A. Okay, so which is present in B but not in A, set A. That's called as proper subset. The symbol is this. Oh, this is the symbol. Okay, this is the symbol of proper subset. So A is a proper subset if I have something extra in the set B. Some notes we have. Subset which is not proper is called as improper subset. Okay, very simple. If A is a proper subset of B, then the set B is superset of A. Superset of A. Okay. Number of proper subsets of a set containing n elements is again given by 2 power n minus 1. What is that, bacha? Because the set itself. We can't take the set itself, right? So we have to remove that one part out. Understand this. If I'm talking about, let's say, this set 1, 2, 3, I can write the set like this 1. I can write this as null set also, nothing is there. Remember, null set, empty set I can write over here. If I'm writing a number of subsets, right, for this, please check. So I can write this as nothing, 1, 2, 3. This is single one, singleton sets. We can write this as 1, 2. Please check. I can write this as 2, 3. I can write this as 1, 3. How many are there? Please check. I have 1, 2, 3, 4, 5, 6, 7. Okay. And what else? 1, 2, 2, 3, 2, 1, 3 is there. Anything else possible? Nothing. Okay. We can do anything else? No. What is the answer going to be? 2 power 3 minus 1. Please check. 2 power 3 is nothing but, sir, 8. What is the answer, bacha? 7. How come 7, sir? Why cannot we take one more? We cannot take 1, 2, 3 in the case of proper subset. 1, 2, 3 cannot be there. Okay. I'm talking about proper subset, right? So in that case, please check. The definition was number of proper subsets of any given set. Let's say this is my set A. For the n element will be 2 power n minus 1. In this case, what is the n, bacha? 1, 2, 3. There are total number of 3 elements. So 2 power 3 will be 8 minus 1 is 7. Count here. 1, 2, 3. This is the null set. Remember? Null set is a subset of all the sets. So null set 1, 2, 3, 4 over here, 3 over here, 7. I've explained you the same thing. Every proper subset is a subset, but a subset may or may not be proper subset. Okay, chaliye. Moving on. So again, you can check this, get this PDF. I'm asking you from the sessions WhatsApp channel will be given, the PDF of the session will be given over there. Please go ahead and download it from there. Okay. So intervals, if you check intervals of subsets of R, what we have, closed interval means this will be including, sir, means we write this as A, B included. Okay. Over here, open, sir. This is open, bacha. This will be closed. Okay. This will be closed, sir. This will open means A and B will be over here written open, sir. A and B will be open. We don't include A and B in the case of open interval. Closed open means this part is closed, this part is open. Here, sir, please check. This represents here A is open and B is, sorry, A is closed, B is open. A is closed, B is open. That is not visible. Okay. So A is closed and B is open. In this case, what is it? Please check. In this case, this will be wrong actually. We have tried like this. A is open and B is closed. A is open, B is closed. This is open, right? And this is closed. So A is open and B is closed. All right. Moving on now. Universal set, bacha. So for any set, please check a non-empty set of which all the sets under consideration will be a subset. Will be a subset is called as universal set. Please check. Denoted by a symbol called as U. Remember, I can write like this in a Venn diagram. This is my U universe, and these are the sets. A, B, I can have more also. Okay, I can have this C over here, let's say. So A, B, C are all subset of the universal set U. Great. Okay. Chaliye. So this is it. I think not much is there. You understand this examples are there. You can go through this, not a problem. Operations, if you check, we have unions where we take the combination except for to remove the copying part. Basically, you cannot repeat itself. Please check. Don't take repetitions in this. Remove the repetitions. Remove repetitions. Repetitions, right? 1 second. Remove repetitions. Okay, and then delete properly. 1 second, guys. Yeah. Repetitions. So you have to remove this. You cannot have the repetitions allowed. Please check over here. I had 1, 2, 3, 4. Here also I had 3, 4, 5, 6. But you won't take 3, 4 2 times. You will not take 3, 4 here, answer. And here also you get only once. 1, 2, 3, 4, 5, 6. There is no repetition. Okay, is there? No. So no repetitions. Okay. Please check. Common elements being taken only once. Taken only once. That's what is the meaning of union of sets. Okay. Next, properties of unions. Please check. A union B is nothing but B union A. Commutative law is true. A union with B union with C is nothing but A union with B and C together, taken at a time, not a problem. Even the associative law is valid over here. Okay. A union with null will be nothing but bacha simply A. A union with nothing will be simply A, sir. Okay. A union A will be A, bacha is called as idempotent law, and universe union with A will be simply universe, law of universe. Okay. Next, what we have, intersection of sets. Please check. Again, you look for the common elements. In this case, you look for the common elements. Please check here. 1, 2, 5, 6, 2, 3, 4, 5. We have answer as 2 and 5, right? Yeah. This is the symbol of intersection. Answer is 2 and 5. Okay. Please check. Some properties are also there. Intersection of A and B is given by B intersection A. Same thing. We take A with B or B with A. Intersection will remain same. What is common between A and B or B and A is the same thing. Okay. Great. We have intersection of A, B, C together. We can take this also. So associative law is also validated in the case of intersection of sets. Intersection of, please check, intersection of nothing with A. Answer bacha will be simply nothing. Nothing is common, right? Null set intersection with A will be null set only. Okay. Idempotent law is there. A with A will be A. Idempotent law. A with B union C bacha will be having there. What is that? Distributive law. We'll have over here distributive law. So for A intersection with B union C will be using distributive law. Okay, please check. A intersection with B union A with C intersection. Okay, so and so basically intersection distributes over the union. Intersection distributes over the union. Okay, disjoint set means nothing is common. What is common, sir? Nothing is common. Okay, we have the common thing as null set. Basically nothing is common, so A and B will be called as disjoint sets. Nothing is joining them. Okay, so disjoint sets. Moving on, difference of sets. Whatever is in A but not in B, that's called difference. Please check. So it's called as something which is consisting in A but not in B. A but not in B is called as difference of sets. Please check here. So I have over here 1 and 2 in A but not in B, right? Yeah. So answer will be 1, 2 and 5 actually. Yeah, 5 also is there. So it is not in B. So whatever is in A but not in B, answer will be 1, 2, 5. Differences, that's how we define it. Let's move on. Properties of difference. We have A minus A is nothing but null set. A minus nothing is nothing but set itself. A minus intersection of A minus intersection of B intersection C will be, please check, will be given by A minus B union with A minus C, sir. Again, A minus intersection of B and C will be given by A minus B intersection of A minus C. Symmetric difference condition comes from here only. Please check. Basically, understand this: the set of the elements that are either present in either sets but not in both. Present in either set but not in both. That's called as symmetric difference. Okay, it can be present in either of the case but not in both. That is called as symmetric difference. Okay, so the result is over here. A minus B. This part, please check. This part is same thing. Okay, even with B minus A. Okay, got it. So we have done questions on this topic as well. Remember, we have done this. Okay, so just remember this formula is very, very important for right now. So for this, for this statement, symmetric difference, understand this. This is the definition, and this is more than enough. This definition is more than enough. What's the definition? Can be present in either of them. Those numbers which can be present in either of them, but not in both. That's called as symmetric difference. Those elements which is present in either of them but not in both is called as symmetric difference of sets. Moving on. Now complement of set, bacha. Yes, this is coming from your Venn diagram. Please check. If I'm talking about A complement, means everything in universe except for A. Though you have to vacate this circle. So everything except for the A will be this shaded part. Got it? Everything. What is the meaning of A complement, sir? Everything but A. Okay, so that's why in the universe everything, so A part will be hollowed, everything else will be part of the answer is called as complement of a set. Okay, please check. We can write this as AC, A dash or A bar or U minus A, means from the universe you take out the A. Please check. Moving on, properties of complement. We have A union with A bar will become a union only. Correct now? This is my please check. This is A complement, right? So you have to remove this part. If you take the union of this, means if you remember this, please check. A complement, if you take union with universe, what's the answer, bacha? Answer will become simply U. Please check. U only. This is a different thing. This is A union with A complement will be simply what do you call union only. Okay, so done. Intersection of A and A dash will be set null set. Nothing is common. Have a look. Nothing is common in this case. Okay, De Morgan's law we have. Remember this properties: A and B complement will be given by A complement intersection with B complement. Again, same goes with intersection also. A complement union with B complement. Okay, if you have union over here, you'll get intersection over here. If you get intersection over here, you get union on that side. Formula is very, very relevant to us. Law of double complement is also there. Same sets repeats. Okay, please check. Laws of empty set and inverse set. Complement of null is universe and complement of universe is null. Okay, moving on now. Please check. So slope of a line. Now we are done with your set theory. This is your straight lines, right? Yeah. Slope of a line, they're asking when the given as line equation is Lx my plus n equal to 0. What's the result? Which result is negative of the coefficient of x upon coefficient of y. Negative of the coefficient of x upon coefficient of y. So minus L upon m. Minus L upon m is the how you find the slope. Very useful to you in the questions. Okay, question is coming from this chapter as well. So very, very relevant. Slope of a line equally inclined with x-axis is given by 1 and minus 1. Remember this case. One line is like this, another one is like this. Okay, this is positive one, this is minus 1. Negative slope and positive slope. Okay, equally inclined with the axis is given by 1 and minus 1. 3 points A, B, C are collinear if and only if slope of AB is equal to slope of BC. Basically, please check here. If I have A here, B here, C, I can say their points are collinear, means this slope M1 should be equal to slope M2 because they are same line, right? So M1 should be equal to M2. If you have that, we can call the lines to be what, sir? Call the lines to be collinear. Oh, sorry, basically the points to be collinear. Got it? Let's move on now. Angle between two lines, we have a result for this. What is that? Tan theta equals to this one, plus minus M2 minus M1 upon 1 plus M1 M2. Okay, so there are more results on this. Please go through this. Okay, have done that. The slope of a parallel lines are always equal. Yeah. For parallel lines, what we get, bacha? M1 equals to M2 for the parallel lines, and for the perpendiculars one, what we get? M1 into M2 equals to minus 1. This part here is the derivation. Okay, this is for the parallel lines, and for the perpendicular we have this. Please check. M1 into M2 equals to minus 1. That's for the perpendicular lines. Okay, moving on, what we have? Slope of a straight line equally inclined to two given lines. Okay, so slope of M of a straight line which is equally inclined, please check, this is the result. So this is the line slope M, you write like this. That's the relation, M minus M1 upon, what is M1, bacha? The first line slope. Okay, 1 plus M1, or M2 minus M1 upon 1 plus MM2, or simply minus of M minus M2 upon 1 plus MM2. Okay, got it? Great. So alright, so this is done. Moving on. Now we have something in the knowledge hub today. Please check. Equation of any line parallel to a given line will be given by this bacha. Please check. This coefficient will remain same, ax by, only the constant will change, c and k. The coefficient of ax and basically of x and y will remain same in case of parallel lines. Only the constant part will change. In case of perpendicular, of course, the slope itself will change. Please check over here. Ax by plus c, and in this case we have minus ay plus k. Sorry, bx minus ay plus k. Okay, so you don't have to remember these forms. Okay, but if you can, good for you. Some formulas over here for conversion of simply parallel lines to each other and perpendicular to each other. Okay, if you can remember, very good. If not, not required. It is not difficult. Remember this concept does. M1 equal to M2 in this case from here, and for this M1 into M2 is nothing but minus 1. This equation is coming from that relation only. Okay, got it? So find the slope from here and use it over here. Slope from here and use this formula to get the result for minus 1. Okay, let's move on now. So what we have, please check. So what we have, distance of a point from a line. The relation is this. When they've given this as your line, ax plus by plus c is given by, please check, c upon root of a square plus b square. Okay, distance of this is in the case of origin. Okay, for the point we'll have ax1 plus by1, because you have the point known, right? So ax1 plus by1 plus c upon this result. In this case, because origin means we have 0, 0, right? So x1 is 0, y1 is 0. So this will become 0, this will become 0, we'll have only c left. That's why we had c upon a square plus b square in this case. Over here we'll have ax1 plus by1 plus c. This is more of a general form. Okay, alright. Length of the perpendicular from a point to a line, again same formula is there. Please check. This and this is same thing. Got it? Okay. What is a, sir? A and b are the coefficient of x and y in the equation of the line. Please check. A and b is over here. C is also from here only. Okay, great. Distance between two parallel lines, bacha, simply the constants will be the difference. Okay, so take here c2 minus c1 and you will have the slope in this case. So if it is not 1 plus m, you can write this also as a square plus b square. Let's say in this case it is given as 1 and m, right? It is given here 1 and this is given as m. Please check, 1 and m. That's why we have taken here 1 plus m square. But if it is not 1 plus m square, you can take this as a square plus b square also. A square plus b square as well in the root. You can replace this and this, same thing. Okay, if this is not given as 1 and m, you can write in this form, a square plus b square, not a problem. Okay, great. If lines are given in the general form, okay, like this form, I have taken over here only, already given over here, please check. Okay, root of a square plus b square. Moving on, mirror image of a point. Okay, so this case is when you have a point over here. Okay, I'm looking for mirror image, right? So over here will come, so this will be midpoint, right? Please check, because this is mirror. This is the mirror, right? So this two will be basically the two ends of the line, and this will be the midpoint. So that's why you have two parts over here. Please check. So you get x2 minus x1. The point is given here, x1 and x2, x1 y1, this point, x2 y2 is this point. Okay, and will be the mirror of the, please check, so this point will be the mirror of this point, x1 y1, and the line, this is the mirror line, is this bacha, ax1, please check, sorry, ax plus by plus c, not ax1, forgive me. This is going to be ax plus by plus c. This is going to be ax plus by plus c equal to 0. Okay, that's the mirror equation, and from there you can use this equation, x2 minus x1 upon a, y2 minus y1 upon b, twice minus 2 times of ax1 plus by1 plus c upon a square plus b square for this case. And if you're talking about only the foot, means if you're talking about only this case, from this point you're talking about this point's coordinate, only this point's coordinate, which is given as, please check, x2 y2. This is given as x2 y2, and over here we have x1, y1, and this equation is same, ax plus by plus c equal to 0. Then we have this equation. Everything remains same except for this 2. This 2 is gone because we have twice the distance over here. We have only one part, right? That's why this 2 is gone. Everything else remains same. Please check. Okay, great. This is for the foot part. This is for the other end. This is for the foot part. Please check this foot, and this is for the other end. Okay, done. Let's move on now. Okay. Now variance, so we have now we are moving to statistics, sir. We are moving to P1 stats, remember? Okay. Now if you check this section, please check if you have the concepts over here is on variance and standard deviations. Okay. So for the deviation, we have the formula as, please check root of variance of the given data set. Okay. X is the data set. We have to find the variance first and take the root of that. How do you find variance, sir? Using this, please check 1 by n root of xi minus x bar. What is this called as? This is called as deviation. Xi minus x bar is called as your deviations, right? Di, d1, d2 like this, d1, d2 like that. So you take that deviations, square of that, okay, and 1 upon n if you take, you're gonna get the variance. Okay, summation of all of these xi minus x bar. What is x bar, sir? X bar is nothing but your mean. What is x bar? X bar is nothing but your mean. Okay, once you get the value, you get the variance from here, okay, and take this root. The answer will be getting for the sigma represents your standard deviation. The sigma represents your standard deviation. Okay. So again, definition is given over here. Please go through it. Of course, we'll also put this. I hope all is okay. Yeah. So we'll also try to put this session PDF in this video only. So please go ahead and download this and go through this formulas. Okay. So check it out here. Same thing is written over here. This is nothing but the variance, root of that. Okay. Same thing is over here when we have frequency involved. In this we don't have a frequency, right? There's no frequency in this case. Okay. In this we have frequency involved. When you have for every data set you have a different frequency also involved. Please check. For that case you'll have this fi xi minus x bar the whole square inside the summation. Okay, great. So this is with respect to 1 by n is taken outside, n is over here. Okay, same relation. Please check. This is also for standard deviation. Properties are also there. When you are adding something, it remains as itself. Okay, variance of xi only, but if you're taking product, it will become lambda times of variance of xi. Okay, if you're taking the sum and product at the same time, this is the sum part, this is the product part, you get a square variance. Remember, the question comes like this, right? If let's say sigma is given something like this value as p, basically the deviation is given as p, and they're asking you every data is multiplied with 2. Then the new value will become twice of p. If they ask you every data is added with 3, it will remain as it is as p only. So in case of addition or subtraction, it will remain as it is. If you're in the case of multiplication and divisions, it will change to the constant that you are multiplying or dividing by. Okay, that's the result you're going to use in the questions. If you check the PYQs, they've asked like that. Okay, now next we're talking about sequence and series. Not much is there for you, only GP and concepts of AM and GM, right? So if you take the general term of GP, please check the formula will be, sir, n equals to a times of r power n minus 1. Please check, this is a general term, a into r power n minus 1 is there. Okay, and if you're writing the sum of this, it will become what, bacha? Please check, s of n will be a times of r power n minus 1 upon r minus 1. Please check, a times of r power n minus 1 upon r minus 1. This is your sum of infinite sum of n number of terms in the GP, right? Please check, where the first term is a, second is ar square, all the way till ar of n power minus 1. Okay, now talking about the relation of AM and GM, AM will always be greater than equal to GM. Yeah, please check, AM is always greater than equal to GM. What is AM, sir? A plus b by 2. What is G, sir? Root of AB. Root of AB. Okay, question can be asked on this property as well, so very important to know this. Moving on, infinite GP series, the formula is a upon 1 minus r. A upon 1 minus r is nothing but your sum of infinite number of series. This also is a very relevant topic. One question is coming every year in this topic. So if you are thinking that this year we will have more questions from the PU1, this can be one of the chapter where 2 questions comes. Okay, so you have this as very important chapter. Simple concepts are there, you can apply and solve the questions on this. Okay, the asymptoticity is given by a upon 1 minus r. Okay, please check. Okay, so now we are done with PU1 section. Now I'm moving to the PU2 part again. Okay, we have done PU2 in detail anyway, but since this is one short formula session, in that we'll talk about all the formula of different chapters. So we'll talk about PU2 also. Please check domain and range of ITF. Important to know sine inverse, cos inverse, tan inverse. First three is very important. First three, sine, tan and cos is very important. Okay, domain is minus 1 to 1. Here tan, in the case of tan we have, please check, in the case of tan we have all real. In case of cos inverse, again domain is minus 1 to 1, and range also is going to be minus pi by 2 to pi by 2. Here it will be open, here will be 0 to pi. Okay, others also there, please go through it and memorize that as well. Questions can be asked directly on this. If you see the PYQs, there has been a question, directly this table is useful and get the result from there. Okay, so yes, this is done. Moving on now, we have properties of ITF. Sin inverse of sin is given by x, cos inverse of cos is given by x. We also have for all these relations cosec inverse of cos, because sir, sin inverse and sin is inverse of each other, right? So if you take the combination, I can write like this also, sin of sin inverse. What's the answer, bacha? X only. Answer is x only. Okay, so we can have the combination this way or this way. Result will be always x, of course, in the given domain. Okay, chaliye. We have few more properties to remember here. Sin inverse of minus x is nothing but minus sin inverse of x. We also have cos inverse of minus x is nothing but pi minus cos inverse of x. Okay, so if you're talking about, let's say, tan inverse, we'll have tan inverse like this. Tan inverse will have the same property. You're gonna get this result as tan inverse of x with the minus sign outside. If you take the cot inverse, we'll have the same result, pi minus cot inverse of x, if you're taking cot inverse of minus x. Okay, so please remember these formulas, highly important and relevant to our preparation. Reflexive, if I'm talking about in the relation and function. Okay, so if we have three elements, for all the elements there should be relation like this: 1, 1, 2, 2, and 3, 3. You cannot have 1, you cannot have 2. You must have all three present in the relation. Then only you can call the relation to be reflexive relation. Okay, if you have only 1, 1, you cannot call the relation to be reflexive relation. You should have all the three ordered pairs available, then only you can call the relation to be reflexive relation. What about symmetric, sir? In this case, if you have ARB, basically ordered pair is A, B. BRA means ordered pair is B, A. If this part is there, this is if condition, then this should also be there. You look for only this condition. If this is there, then this is there. Don't worry about other things. Okay, this is there, then this is there. In this case of transitive, we have two conditions. We have ARB, so we have BRC. These two are both if conditions. Okay, and then condition will be ARC. I wanted to again remind this thing to all of you. If you cannot check, if there is no way to check for your transitive relation, the relation will be always transitive. If there is no way to check it, no way to check, the relation will automatically become transitive. For example, I can take 1, 1, 2, 2 and 3, 3. Can you check this transitive over here? You cannot, sir. There is no relation like AB, BC and AC. In that case, we don't have to check. Just understand this will be a simply transitive relation. This R will become simply transitive. Yes. Okay. And the combination of all three is called as equivalence relation, bacha. Which means when we have the combination of all the three together, if a relation R is given like this, please check. We have a relation R as equivalence. It means it has to be reflexive, symmetric and transitive at the same time. When we have all the three, we call the relation to be equivalence relation. I hope this is all okay. Now if you see your your game plan of this thing, so most of the time, okay, this year they might ask more, but usually they ask 15 questions in the PU1 category. Okay, 15 to, let's say this case, maximum of 20 they can ask. Over here 40 to 45 questions are coming in the PU2, so please give more energy, more revision to the PU2 section. Okay, good thing for us is in the PU1, if you check the PYQs, right, usually questions are very simple. Questions you will find simple categories one. Okay, means almost 8 to 9 questions bacha will be of easy category in the PU1 section. If you check this out, okay, means 8 to 9 of 8, every 15 question if you check, okay, it'll be easier. Means basically which the classification states to us 15 over here, 30 over here and 15 over here, right? Total 60 questions are there. So in that, these 15 questions only, most of the questions in the simple category or easy category can be from from the PU1 chapters. So if you know that, if you revise that formula, if you have learned the formulas, you can solve those questions and easily get 45 to 50 marks. If you have studied properly, you can easily get 45 to 50 marks in maths. Okay, you can get 10 marks over here. You can try to score out on this category. You will easily get what, bacha? You easily get 45 plus marks in your maths examination if you have a proper planning, if you have a revision of the concepts. Give priority to PU2 and revise the simple topics in the PU1 to score that 8 and 9 marks easily. Got it? Okay. Moving on. Now this I already told you, for a relation to be equivalence, you should have all the three. You should have, this is for reflexive, right? This is for symmetric, right? And this is for transitive. You should have all the three together, then only you can call the relation to be equivalence relation. Okay. Now what we have the types of function, please check. One function will be when we have the cases of this. Whenever we have the case of, if you draw the graph, you get only one intersection. In this case we have two. They'll say not 1 1, not 1 1. Okay. When we have only unique intersection like this, we call the function to be 1 1. Okay. Chaliye. Simply if you look at the algebraic form, if f of x1 equals to f of x2, we have x1 equals to x2, and if basically f of x1 is not equal to x2, f of x2 will have this also not equal. Means then when it is equal to, not equal to, not equal to. I hope you get it. In the case of, so this will be just ulta of that. Whatever is 1 1, ulta of that will be many 1. Okay, means whatever has, think about it, we have combination of not equal to and equal to over here. So this is will be, sir, not 1 1 means basically it will be many 1. Please check, it will be many 1. Okay, great. All right, now moving on. Another way to find this picture will be basically find the derivative if f dash of x is either greater than 0 or less than 0, either of the case. It can be this or this, not both. Okay, then you can say function will be unique in nature, increasing, or here decreasing in nature. We can say the function will be 1 1 function. Got it? Decreasing or increasing, both. Bacha, if you have only one nature, no, the function has only one nature, not both, only one, either this or this. Okay, then we can say function will be 1 1 in nature. Now we have onto. For onto, what we do, we have a shortcut. Remember, when x you try to put it to infinity or tend to infinity, the function again should move to infinity only. And if I take x to negative infinity, the function fx should move to negative infinity. This is called as onto function. If you're getting this relation, we'll call the function to be onto. Okay, what is the understanding of this? If you can prove, bacha, simply range of the function to be equal to codomain. If the range and codomain is equal, we can say the function is onto function. This will be ulta of that. Opposite of the into will be your, sorry, opposite of onto will be into. Okay. So whenever you have a range and codomain equal, is called as onto, not equal is called as into. This is the trick to understand and find the function to be onto or into. Okay, so both should be there. There should be both, this and this both should be there. If that is the case, then we can say the function is onto. Okay, now if you look at this new chapter, which is continuity and differentiability, high weighted chapter, 6 questions are coming from here. So you have to know all the formulas over here. What is that? Looking for continuity, sir. So limit of the function at any point should be equal to the function value at the same point C. Okay, what is the meaning of limit, bacha? Limit means both LHL and RHL should be equal to each other. So LHL should be equal to RHL, should be equal to the function value at C. Don't check one, check all of them, check both the sides. What usually we do, we check any of the limit and put it equal to the function. That might be wrong in some cases. So please cross check, please cross verify for both of these. LHL and RHL, both you cross verify. Okay, so they should be equal and should be equal to f of C as well. That's the continuity of a point. Okay, the point where the function is continuous is called as point of continuity. Please check. If a function, okay, now we talk about differentiability. Same thing, bacha. You try to define the function again, redefine the function as a critical point, at critical point, okay, or the point which is given on that point. And secondly is what you call, check the RHD and LHD. Find that left hand derivative, right hand derivative. If they are equal, we call the function to be differentiable. We call the function to be differentiable. This is differentiability. Okay, differentiability, sir. Is that clear? If we have RHD and LHD both equal, for example, if I take, please check y equals to mod of x. Define this function once more. We have x and minus x for x more than 0 and x less than 0. Differentiate this. What I get the derivative? Y dash bacha will become equal to 1 and minus 1 for x less than 0. Sorry, it's like this. Please check. Greater than 0, we have 1, and less than 0, we have minus 1. Are they equal, sir? No. So left hand derivative is minus 1 and right hand derivative is plus 1. They are not equal to each other. It means the function will be non-differentiable. Will be non-differentiable. Check the graph. Non-differentiable. The result is non-differentiable, sir. Non-differentiable. Another way to find it out, if you can see a sharp curve, edge in the function or break in the function, means there's a gap in the function, you call the function to be non-differentiable, sir. Okay, so how can I identify this? Please check. Okay, and this is understanding, of course. If it is discontinuous, means it will become automatically non-differentiable. If a function given to you is discontinuous in nature, it will be automatically non-differentiable. Okay, another way to identify this bacha will be a break. If you have a break in the function, first nature, second nature, if you have what you call corners or edges, you have corners or edge, please check. Okay, I can write corner only, it will be better. If you have corners or sharp edges, if you have corners, for both the cases, if it's there, you're going to call the function to be non-differentiable. Non-differentiable. Is this clear? So first of all, discontinuous means non-differentiable. If these cases are there, break or corners are there, you call this function to be non-differentiable. I have given you this define as well. So redefine it and at the critical point and check for the derivatives. If they're equal, then differentiable. Clear? Moving on. Some formulas are there for ITF. Please remember these formulas for sine inverse, cos inverse, tan inverse. These are most important formulas. First three, okay, used in substitution of the questions and integration as well. So very, very important. Please check. Moving on. Basic properties of logarithms. Okay, so please check. When we have the product rule, we take this as log of m plus log of n. We use this in the cases of integration. When we're talking about LDE in the differential equation also, so we use this property. So please remember this. Okay, integration, when we're talking about, when we have the product available, we take log on both sides, okay, and try to differentiate from there, okay, or integrate from there. Chaliye. Usually in differentiation also we take integration, also we use these properties of logs as well as in differential equation. So basically throughout the calculus we keep using this properties of log. Okay, this is the base change. We have done questions on this, remember. Just only one thing is, try to keep this, whatever is the change, same. So whatever is the number over here, e, same base will come for the next log, same base will come for the next log. Okay, let me raise these markings so that it is clear for all of you. Okay, this is the quotient rule. All right, we have few more rules which is very, very relevant to us. Please check. So we can write this as, remember, if I have a log of, let's say, x power m and I have y power n, okay, means the base is also having a power and log value is also having a power. So what are you going to do? You take this m over here and it will also come. So answer will become basically m upon n log of x with the base y. So this m power will come as the coefficient in the numerator, this n will come over here as the denominator. So m by n will come, m by n will come. Remember this property, very, very useful to us. The parametric form, what do we do in this case? If I have, let's say, a parameter, let's say given like this, y is given as, what do you call, some function, basically I can write here as, let's say, function of theta is given, okay, f of theta, okay, and some function also x is given as g of theta. Okay, so what are you going to do in this case? You're gonna write, you are looking for dy by dx, so you write here f dash of theta upon g dash of theta. So basically you're gonna differentiate f with theta and differentiate g with theta. What is meaning of the bacha f dash of theta? F dash theta means df by d theta, right? Same way you have for g dash theta, dg by d theta, and you take this in the form of a derivative of the ratios. Okay, that will be the result of dy by dx. Okay, result of dy by dx. So you have the parameter as theta, differentiate with theta first, both the functions f and g, and then you take the result with the ratio of the those two functions derivatives. That will give me dy by dx derivative in the parametric form. Done. Next we have the second order derivative. Please check, questions can be asked on this. What is second order derivative? Derivative of the first derivative is called as second derivative. Derivative of the first derivative is called as second derivative. Please check. We have some notations over here. The notations are like this: f dash of x, f double dash of x, dy by dx, or d square means the same thing, bacha. F dash of x is same as this or y1. Okay, same thing, this part, and y2, y double dash is also same as y2. They're all meaning of, so y2 you can write this as y double dash, you can write this as f double dash of x, you can write this as d square y by dx square. All has the same meaning as second derivative. Second derivative. Please check. Okay, moving on. What do we have next? AOD. Now in this chapter when we talk about, we have three sections of application over here. Remember, one was in the case of One was in the case of your rate of change, okay. Other is the case of your increasing decreasing function, increasing and decreasing function, and the last is maxima minima. Last is maxima minima. What you do in the case of rate of change, you can usually find the question with this. Remember, function v is given in terms of, let's say, some function of r, and you write this dv by dt you usually find, okay, as basically differentiate f dash of r. Please check f dash of r into dr by dt. You find it like this, remember, okay. Or you also can find this dv by dr, it will become simply f dash of r. In this case you won't have dr by dr, okay. Two type of question comes usually when dv is differentiated with time or with the radius, okay. So both type of questions can come. Please practice some of them, or I think you already know it, so you don't have to practice. I'm just giving you the idea what type of questions can be asked in this, okay. Increasing decreasing function, please check over here. But in this case what do we do? Find the derivative of the function, okay, and from there you put it equal to 0 to get the critical point, all right. And whenever the derivative is more than 0, we call the function to be increasing in nature. Less than 0, we call the function to be decreasing in nature. Less than 0 means we call the function to be decreasing in nature in the case of less than 0. Maxima minima, again we have two tests in this. First derivative test, second derivative test. Usually I'm going to suggest you to use second derivative test, okay. What you do in this, you find the f dash of x, put it equal to 0 to find the critical points, okay. Get the critical points from here, and then find double derivative of x, okay. If this is coming as less than 0 or more than 0 at the critical points, we call this to be max or minimum. According to that, this will be minima. Please check. Greater than 0 means minima, less than 0 means maxima. When the second derivative is less than 0, it is maxima, greater than 0 is minima. Please use these concepts, okay. Chali. Now increasing decreasing function you can check here. Of course, these are the definitions of increasing decreasing function. If you want, you can go through this. I'll tell you one difference over here. Please check increasing function, strictly increasing function. Whenever you have the difference, what's the difference over here, bacha? Here the symbol is this, here the symbol is this. There will be no equality in the case of strictly increasing function. The graph will be different. Here the graph will be increasing like this and then again increasing. Over here it will be always increasing in nature. It will be always increasing in nature. Same way in the decreasing case, please check. In the decreasing case you will have decreasing constant and then decreasing again. In the case of strictly decreasing, you will have the function straightforward decreasing all the time. Decreasing all the time, okay. Please check. So the graph is very important. Over here we have less than equal to, we have only less than in this case. That's how we differentiate the function in the case of strictly increasing, strictly decreasing, and increasing and decreasing, okay. This is clear. I don't think the graph will be that looking good, so I'll just make this little bit change and make it useful to you, okay. All right, that's the curve in the strictly in the decreasing case, and this case we have the curve as simply this, decreasing. When x increases, y decreases. Here when x increases, y increases. That's the increasing case, okay. How do you find it? By finding the derivative. What do you do in this, bacha? For f dash of x you find, okay, you put it equal to 0, all right, and then you take, let's say you got two critical points, c1 and c2 is critical point. So right here c1, right here c2. So if the x coefficient in this is positive in the derivative, you write here plus minus plus. Wherever is plus means it will be increasing cases, negative means decreasing cases. Please check. So in this interval you will have increasing and you will have this as decreasing. If I check this question out, please check. Y dash will have 4x minus 0, right? This is 4x minus 0. Put it equal to 0, I get x value as 0. So I have only one point over here, number line. 0 is the only point. Please check the coefficient of x, bacha. Coefficient of x is positive, 4 is there, right? So right here plus. If it was negative, no, we'll write here minus, okay. Minus here, I'm looking for, let's say, increasing. So this is my increasing section, this is my decreasing section, okay. So for this we'll have 0 to infinity. If I am having the case of strictly, I'll write open. If I'm looking for strictly increasing, okay. If I'm looking for increasing, this is for strictly increasing, bacha, okay. If I'm looking for just increasing, I'll write the close interval. If I'm looking for just increasing, right, only I'm looking for increasing, bacha, then I'll write 0, close and infinity. This is for strictly increasing. This is for strictly STL, right? Strictly increasing means you'll have open 0, this will be closing 0 if you are looking for only increasing. Please check. Okay, decreasing, you'll have again this value negative infinity to 0. We'll have negative infinity to 0 as strictly decreasing in nature. Done? Okay. First derivative test for maxima minima, don't do it. It will be lengthier in nature. I've already taught you, but it will be lengthier in nature. Don't do it. Use second derivative test. Derivative test. What do you do in that? F dash of x you find, put it equal to 0. From there you get all the critical points. Critical points you find from here. Let's say the points are A and B are the critical points. Sorry, the critical points are A and B. Okay, and from there what you're gonna do? Find f double dash of the function. In that you put the value to be f double dash of A if it is coming as less than 0, and f double dash of B if it is coming as greater than 0. We call this to be the case of maxima and this to be case of minima. Please check. Less than 0 means maxima, greater than 0 means minima. Okay, so please ignore bacha the first derivative test. I've already taught you. If you want, you can revise it from my previous sessions of AOD. Okay, moving on now. Second derivative test, I've already done this. Please check. Have done this part over here. I've done this part over here. Okay, let's move on now. Now we are moving to integration. Okay, what we have in this? Whenever you can find bacha questions derivatives present means whichever derivatives, for example, you check here, phi x is there, derivative of phi is over here. So you're gonna make this to be substitution. So look for derivatives. If you have derivatives present in the question, that function, okay, that particular function, let's say fx derivative is present in the function, then fx bacha becomes your substitution. It becomes substitution. Please check in this all the cases. Here we have f dash of x present, right? It means my fx is substitution. Over here also f dash of x is there, it will become fx as my substitution in the case of the variable t. Okay, great. Some examples are given here for the table. Already explained you guys. Please go through this, download the sessions PDF and go through these substitutions. Okay, why I'm using this over here? Because if you take a sine theta, no, over here it will become a square minus a square sine square theta. Okay, you take a square common, right? You'll have 1 minus sine square theta, so it'll become a square cos square theta. Root will be there, right? In all the cases it'll become simply a cos theta. So question becomes simple in these cases. So whenever you have these forms, you try to use this substitution of trigonometry. Have a look. Okay, next what we have, particular functions are there. Please remember these formulas. In this, if I have to highlight some formulas, very important ones, so I'm going to ask you to remember. We have for sine inverse, this is very important. Then we have for log also. Okay, tan inverse is also very important. Okay, these two are very important. Okay, sine inverse, log inverse, and this also is important. So okay, this also. So 1 here, 2 here, 3 and here 4. These particular functions are important formulas. Others also you can remember, but these are again very important. If you have to give a preference, give this 5 as a preference, but first should be these two. Sine inverse and tan inverse are highly important. Remember these formulas. Okay, very important. Chaliye. Now for the partial fractions, I have given you tricks. You can remember these all, good for you, but in my short tricks video I have given you tricks in partial fraction. Please use that trick. Please go ahead right now and watch my short trick video. It will not take much time. I think 20 minutes time it will take, 10 minutes of time will take. You can watch in the fast, just move to the point where I'm taking you and explaining you this partial fractions. There I have explained this part. This is very important part. Okay, that's where the question comes from, so please work on this. Okay, I have given the trick on this, so please go through that. Okay, got it. Now moving on, by parts question will be coming from here, bacha. By parts combination with substitution question will come pakka, 100%. Okay, if not 190%, I'm giving you the chances that a question of the substitution on the integration with by parts is coming for sure. You can see any mock, any PYQ, you'll have one question on this pakka coming. Okay, so please remember this by parts formula. What you do in that, you have to check the preference. So let's say over here, this is my function number 1, function number 2. How you choose the preference? Using this condition, I let inverse, log, algebra, trigonometric, and then comes exponential. So first function as it is, second function integration, minus first function derivative, second function integration, product of that, then that result of the product should be integrated one more time. Okay, this is again some more integrals of particular functions. Not many times they have asked it, but if the question comes, if you don't know these formulas, you cannot solve it. Means if the question is like this coming, it can be either very difficult or very easy. If you know the formulas, very easy. If you don't know, you cannot solve it only. Okay, you don't have time to derive the result. So please remember these formulas. Okay, if it is coming, you know the form, just use directly. You can choose the correct option. So why you don't want to take a chance? Please remember these formulas. Next, what we have, properties. In this properties, sir, some of the very important properties are here. Please check over here also, right? And the property of odd even function, they keep asking. Okay, they'll give you the function combination of odd or even, or odd or even like that. You have to pick this option. For odd condition, you get the result as 0. For even, you get the result as 2 times of the given integration from 0 to a. Okay, and this also is very important. I've given the tricks on this integration. Remember a plus b minus x when we're talking about tan cot question, sin cos question. So those questions, remember where we used to do this, upper limit minus lower limit by 2. That's my answer for the integration. Remember, that was based upon this trick only. Please check. A plus b minus x we replace, and we try to make this question easier for us. So this property is where we use that particular trick in the integration. That question will be coming for sure. So please go ahead and watch my tricks. Okay, chali. This is done. Properties of addition of the matrices. Very simple chapter bacha. A plus b is same as b plus a. Commutative is true. We have a plus b plus c, same as a plus b plus c. I can take a plus b together or b plus c together. Also true. We can take a plus 0 or 0 plus a, same as a. So simple properties are there, not much. We can write a plus minus a as 0. Same goes with minus a plus a. Okay, I can cancel this a and a together. It's called a left cancellation. Cancel this a and a over here, called as right cancellation. Okay, great. Properties of scalar multiplication, I can multiply a scalar in any format. Please check, these formulas are there. Go through this once. Okay, moving on. Properties of matrix multiplication. AB is not always equal to BA, only possible in the case of inverse. If the inverse is there, then only this will be possible, otherwise not possible. Means multiplication is not commutative. Please check. Okay, this is there. We have associative law true over here. AB times C is same as A times BC. Okay, this also is true. Distributive property is also true, bacha, in the case of matrix multiplication. Just understand this. The understanding of multiplication should be valid. Means basically, I went a little fast over there, but it's okay. Please check. Means AC should be defined. I can multiply AC. For example, number of columns in A should be number of, it should be equal to number of rows in the C. That property should be validated. Okay. Property 4 is there. Even though A and B are not null matrix, I can have AB as null matrix. Means let's say I have A as not equal to null matrix, I have B as not equal to null matrix, but I can still get AB equal to null matrix. I can still get AB equals to null matrix. Okay, that is there. Okay, chaliye. So that property is there. Please revise these properties. Okay, great. Property number 5, have a look. A into I is same as IA, simply same as A. A into 0 or 0 into A is same as 0 or null matrix. Okay, transpose, bacha, nothing is there. Just make this row into column 1 2 3 1 2 3. Here also row into column 2 0 5. The row becomes column. So the row becomes column. Okay, that's called transpose. All right, property of transpose, if you check, we have A plus B transpose as simply A transpose plus B transpose. Okay, and if A is any matrix, we can write this A transpose is simply equal to A. All right, and we have in the difference also same thing is there. A transpose minus B transpose is all right. If I'm looking for, let's say, negative of A, the transpose, answer will become simply minus of A transpose. Please check. Property 4, if it is the multiplication, if I'm taking the multiplication transpose, B will come front, A will be after that. Since if I'm taking this 3 matrices A, B, C, C will be first, then comes B, then comes A. So A, B, C is there, here it becomes CBA transpose of individual matrices. C transpose, B transpose, A transpose will be there. So that's the property here in the case of multiplication. In the case of multiplication. Alright, got it? Looks confusing, so I'm going to simply erase this part, not required. Okay, this is the case of multiplication. AB will become BA if you're taking the transpose. Okay, Moving on, symmetric and skew symmetric matrix are very simple. If I have a matrix, of course this is valid for only square matrix, only square matrix. Okay, so you get bacha A transpose equals to minus A. This will be your skew symmetric matrix. Okay, this is for skew symmetric matrix, skew symmetric matrix, and for symmetric part what we have A transpose is equals to A. Please check. Okay, inverse macha, you know this very well. Inverse will be given by, remember, adjoint of A upon determinant of A. Okay, all right. So for one matrix A, you will, if they're saying that there are two inverse exist, means we have B inverse and C inverse. It means that B inverse will be equal to C inverse. Means for any given matrix, if it is invertible, they'll always have unique, means they'll always be equal. Means basically inverse will be always unique. Inverse of a matrix is always, understand this, unique in nature. Always will be unique in nature. Means if I have a matrix A, for this I have two inverses, B inverse and C inverse, they'll be equal to each other because they'll be unique in nature. This works. All right. Direction ratio and direction cosines, please check. Ratios and cosines, we have this as, we write this as A, B, C, remember, and this as L, M, N, remember. The properties of L, M, N is L square plus M square plus N square is 1. Also L equals to what bacha? Cos of alpha. M equals to direction cosines, no? So cos of beta and cos of gamma is N. What is alpha, beta, gamma? The angle with x-axis, y-axis and z-axis, of course in the positive directions of x, y and z. Okay, so if you want, I can write this value of L actually in terms of ABC. So L will become A upon root of A square plus B square plus C square. Same I can do with M also. M will become B upon root of A square plus B square plus C square, and I can write N also same way. N also same way I can write, bacha, same thing. C upon A square plus B square plus C square. Looking for shortest distance, you don't have to know in both vector and image, what do you call in the Cartesian form. Just remember one of them will be good enough for all of it. Right here, A2 minus A1, this dot with B. Okay, if it is given as one vector, if it is given as two vector, you have to write cross product over there. So let me just do that. If it is given as one vector, write simply B. But if they are given two vectors, okay, then you have to take B1 cross B2 mod divided by mod of B1 cross B2. That's the formula for shortest distance between two vectors, or two lines actually, in the vector form. Okay, in the vector form, please check. Now we have what we have over here, equation of a line through a given point. What we do, bacha? This is the point, and the point is, sir, x1 comma y1 comma z1. So we write here x minus x1 upon L. What is the L, bacha? The direction ratio, sorry, cosine of it. So x minus x1 upon L, y minus y1 upon M, and z minus z1 upon N. This is the formula in case of Cartesian form. In case of parametric form, we have same thing, where the parameter is R. Please check. We have x minus x1 upon L. Basically x becomes LR up plus x1, y becomes MR plus y1, z becomes NR plus z1 in the parametric form. Please check. Again, if you're looking for vector form, we'll show that vector form will be like this, bacha. Will be, please check, vector will be given as R equals to we'll have vector A plus lambda vector B. Lambda vector B. What is vector A going to be? x1 I cap, y1 z cap, and z1 k cap. And vector B will be L I cap, M j cap, N k cap. I'll repeat myself. Vector A will be x1 I cap, y1 j cap, and z1 k cap. B will be L I cap, M j cap, N k cap. Okay, done. Alright, angle between two lines, please check. The relation is given in this case, cos theta over here in terms of direction ratios is over here. In the case of direction cosine is over here. Please check. Okay, this is for DCs, this is for Rs, and this is for DCs. Angle, cos theta and cos theta. Okay, great. Condition of perpendicularity, what you get? Cos theta will be 0, no? Theta will be 90, means what I have? Cos theta is, please check, 0, right? It will be 0, sir. So that's what it is over here. Please check. Okay. If it is parallel, you take the ratio, bacha, will be equal. Remember from where you get here? If it is parallel, means B equals to lambda A. we have this is as the collinear form, remember? So it will be ratio will always equal. So L1 by L2 equals to M1 by M2 equals to N1 by N2. Okay, I've already given that formula, please check. Okay, same thing also I've given. If it is perpendicular means, say if it is intersecting means, what will happen? If the two lines are intersecting in nature, it means the shortest distance is going to be 0. Lines are intersecting means shortest distance will be 0. That's why I've taken this value shortest distance equal to 0. So hence the numerator will be 0. Numerator will be 0. Please check. This is the numerator, right? Dot of A2 minus A1 with B1 cross B2. Got it? Okay. Next, what we have, Cartesian form of the same thing. If you can remember this result, good for you. Otherwise, you can use this vector form also. Same thing is there. Okay. Great. Now we have the last thing, which is base theorem. Have a look. What is there, bacha? Very important. If I have, let's say, E1, E2, E3 are the partitions of any given, event. Okay, any sample space is given, and E1, E2, E3 are the exhaustive, mutually exhaustive, and so exclusive and exhaustive events. Basically, what it means is, exhaustive means if I take E1 plus E2 plus so on till En, right? I get the answer as simply universe. Okay, or the sample space S. If it is not inverse or sample space S, basically, or sample space S, this or this. It's not divided, it's this. Basically, I mean this. Please check. If I have, let's say, event E1, event E2, event E3, event E4 like this, this is sample space S or U, whatever it is, they'll become that. It is the meaning of exhaustive events. Mutually exclusive means, bacha, I don't have any intersection available for them. Okay, that's the mutually exclusive. Please check. So the result is given as, for the event A has already occurred, I'm looking for event EI's probability. It will be given by, please check, like this. This is called as, this is coming from your probability result of conditional probability, and this is coming from your total probability. Please check, total probability. What is this, sir? Intersection of event EI or E1 with A divided by P of A. Okay, what is P of A, bacha? Simply total probability. Means for the event occurring A, when the event E1 has occurred, event E2 has occurred, means, okay, like that we have to take. Okay, same thing. For the numerator we have coming from conditional probability. Okay, independent events, what we have, so when we have nothing in common, right? So please check, when the occurrence of one event does not affect the occurrence of other event or non-occurrence of the other event. Okay, please check. So we have the result as intersection of A and B will become equal to PA into PB. We have a lot of questions on this. And this becomes such a simply PA. How come is this? Please check. P of A conditional with B will be nothing but, we have the formula. We have this as P of A intersection B upon P of B, right? If it is independent event, I can write this as simply numerator will become PA into PB, right? Divide by PB, cancel, what I get the result as simply PA, sir, simply PA, sir. If I'm having three events, I'll write this as P intersection of A with B with C will be PA into PB into PC. Please have a look. Okay, so important results from your probability is also covered. So I hope I have covered almost everything which is there. If I have missed something, I have given the sessions on the master stroke sessions in what you call your top 30. So if you have to do something, please revise these formulas. PDF I will give right now in the video itself. Okay, apart from that, if you want to do some PYQs, I have done PYQs in top 30. Go ahead, check that out. Okay, especially for PU1, I have done PU1 in 4 sections. I have not done many. Only 4 parts I've done all the PYQs. Go ahead, check the PYQs of PU1 in part 1, part 2, part 3. The last 4 sessions of top 30 are having PU1 PYQs. Please go ahead and solve those questions. Okay, PU2 I've done top 30's other sessions, so you can go ahead and check that out as well. So with this, I'm going to end the session today. I wish you all the best. I hope you do really good in mathematics. And again, I'll see you after the session of maths in the evening with a paper, basically, analysis. I'll come here, see your question paper, discuss the question paper, give you answers as well. Okay. So I hope to see you again very soon. All the best. Keep working hard. Okay, I know last minute is there, but yes, you have to work really hard right now, and of course take some rest after some time. You have planned a strategy, because bacha, in math exam you have to be very fresh before the examination. You cannot think too much or too many things before the examination. You have to keep yourself fresh. Don't talk to your friends, don't solve new questions, do not do that. It'll chip away the confidence. Sometimes what happens is confidence is better than because a bigger tool in the examination. Okay, so keep yourself confident going in the examination of mathematics, and there are a lot of things which will go your way if you are positive in the examination. Don't look for different or new questions. Whatever you've learned, focus on that. I know you might be anxious in the examination, but it's okay. accept that. It means that you want for it to go very good. That's why you're anxious. Okay, just back your strength, back your understanding, back your preparation, that you're gonna do really good in the examination. All the best to all of you. You know, my blessings, my love is available for all of you. Okay, I wish all the best, and I hope to see you again very soon in the live session. Please join that, and we'll discuss the paper. Till then, take care. Bye bye. All the best.